Okay, so in this video, I'm going to start talking about the abstract data type called linked lists. Right, so what's a linked list? A linked list is a series of nodes that are connected in a chain. Right, so what do I mean by this? Right, so a node consists of, you can imagine it if you draw it at like a little box. Right, the node consists of two things. One, we have a value, and then here we have a pointer, right? And that pointer is usually called next, right? So our data goes in this area here for value, so we have 5, and then the pointer usually points to the next node. All right, so then we create another node, and then the same thing. It has some sort of payload, some sort of data, so maybe the number 7, and then this one will point to the next node. And then maybe this is 8. And then at the end of this chain, the last node points to null. Right? And then to get access to this linked list, usually we have another pointer called head, and head will point to the first node. The difference between this and maybe an array is that we can add values to this linked list, right? This can grow dynamically, whereas an array we have to set, a certain size before initializing it. So this is good for dynamic allocation. Okay, so, and remember, each one of these is called a node. This is a node, this is a node, this is a node. All right, so how do you actually make the nodes? Here, let me show you. Okay, so to make the node, we need to first define its structure, right? So we can use a struct. We can call it something like node. And the node, remember, consists of two things, right? Usually some sort of data, so int, in this case we'll call it value, and the pointer to the next node. So the pointer is going to be of type node, and we're going to call it next. Right, and because of the fact that this struct has a pointer that points to another struct of the same type, then we can call this this data structure is called self-referential, right? Because it refers to itself. And then the other thing we can do here is we can define a constructor, right? So we can call the constructor node, and it'll take two arguments, int v and a node pointer, and we can call it something like just next one. Right, and then the value here, the instance variable will assign the parameter v, will assign the instance variable the value of the parameter v, and this pointer called next will assign it the value of this parameter. So that's next one. Right, but what happens if we make a node and it's the first node? All right, so let's take a look at a diagram real quick. All right, so let's say we make the first node. Let's say it's something like this. and it consists of two things. We'll do our payload, our value, 5. But this pointer here, what's it going to point to? This is the first value, right? Well, it's going to have to point to null, right? It has to point to nothing. Excuse me. So to do that in the constructor, we can set a default parameter. We'll call it null. Yeah, so a default parameter, if nothing is passed, if we only pass one value to the constructor and nothing for the second parameter, then it'll automatically assign null to the instance variable. So we'll see how that works in a little bit. Okay, so if we go back to our diagram here, we also need a pointer. Here we'll call it head, and that pointer has to point to the first value, right? Because this head will help us keep track of the linked list as it grows. So let's try it out. Okay, so let's start creating this list. So we'll create the first node. So we'll call it list node, or I'm sorry, node. This will be the head, and we'll start off with null. Okay. Now here we'll set head equal to new, call the constructor node, and we're going to pass, we have two options. We can either pass, we can do it like this. Okay, so what we're going to do is we're going to pass maybe the value 5, like our example. And since we don't have another node to pass a value or a pointer to another node, we're just going to leave it like this, right? And this will compile. Okay, but it's not going to display anything yet. That's okay. So I'll show you how to display in a little bit. All right, so that works okay. Now, the next thing we need to do is create another node. Now, the other node, what we're going to do is we're going to reassign the head, and we're going to make this equal to new node, and then let's say the value 7. But here, now we already have a node, so we're going to assign the value, or we're going to assign what's being pointed to by this first pointer here, like this. That looks a little odd, but let me draw it for you on the diagram, and it'll make a little bit more sense. Okay, so this is what I did. Alright, so I created another node. Pass it the value 7. And what I did here was this head, instead of pointing to this value, now head is going to be pointing here to 7. And then the next on this guy is pointing to 5. Alright, so it's going to look like this. So if I draw it a little bit better. Okay, so it's going to look like this. We have head here. Head is pointing to the value 7. Then this 7 is pointing to 5. And 5 is still pointing to null. Okay. So then let's create a third link in our chain. So we'll reassign head. Head is a new node. And then we'll do the value maybe 9. And we'll have head here. Okay. So now I have this. And then head is moved here. And then right now I'll show you why we need this pointer here. Without head, we wouldn't be able to access this. Right? If we lose this variable, or we don't update it, then we'll lose our access to this entire link, this entire chain. Okay. So now that we have 3 links in our linked list, let's go ahead and see the values. Right. So let's see out. Let's get to head. And head, since head is a pointer, rather than trying to access these instance variables or these members of the struct, trying to access them like this, it won't work. Right? We need to use the arrow operator. Right? And then with the arrow, now we can access the values. Right? So let's access the first value of head. Head started off initially as 5. Then we created a new node with 7, and then we created the last node with 9. So remember, it looked like this guy here, 9, 7, 5. Okay, so let's see that out and see what we get. Control F5. Alright, so it shows us the 9. Okay. Good. What if we want to see the 7? Right. Then we could do this. We go through the head. Then we point to what head is pointing to. We go to next. Then whatever next value is, we display it. Right? So then now that's going to show us the 7. So it's going to show us 9, then 7. So Control F5. So let me increase the size of this a little bit. Alright, so now we see the 9 and the 7. Okay. So now what if we want to see the 5? Well, then we're going to do the same thing. We're going to go through the head. Then we're going to point to next. And then whatever that next is pointing to. So next. And then finally, the value. Alright, so now we should see 9, 7, 5. Control F5. Alright, so 9, 7, 5. Right, and we can keep adding to this. Reassigning the head. Head is now new node. We'll do 11 since for some reason I chose odd numbers. Okay. And then here we'll do head next value. right? And then that should show us, it should start with 11, 9, so this is 11, 9, 7, and 5. Yeah, there you go. Okay, but this method of going next, next, next value, next, next value, next value is not very convenient, right? What we can do instead is we could use a for loop to do this. Right, so let me show you how to do that. So to display the values, excuse me, we use a for loop. Actually, a better idea, not a for loop, sorry. What we can do instead, let's get rid of this. What we're going to do is we're going to create a new pointer of the same type, right? So node, we can call it PTR, and we're going to assign it the address of head. Right, so, and the reason we want to do this is we're going to change the value of this pointer, but we don't want to change the value of the head. Right, we want head to continue pointing to the first node in our chain. Right, so we can use this, it's kind of like a temp variable. We can modify it, adjust it, and then delete it when we're done. Right, but the head, we want to make sure nothing happens to it. Right, so it's better off that we create just a different pointer. And then what we can do is, let's say we don't know the size of our linked list. We could have 3 values, 4 values, 10 values. We don't actually know. So the best thing to do is just to make sure that while PTR does not equal null. While it's not null, go ahead and keep running the to display it, right? And then what we can do is cout PTR value. So we'll display the first one, and then once we display the first one, then let's move the pointer. So then we'll do PTR equals PTR next. Okay, so let me try to run that. Control F5. Right, so that displays our values, except maybe it would have been a better idea if I had put some space on it. Okay, let me try that again. Something here, we'll just do an inline. Right, so it displays 11, 9, 7, 5. And we didn't have to keep going through next, PTR next, 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 or head. Right? PTR changed because we reassigned it, but our head, we kept it where it belonged. Right, so let me show you. Okay, so with the magic of editing, I went ahead and I redrew this list again, since my last version of it was going off to the side. Right, so here's the linked list we created. Here's going to be the head pointer, and it's going to be pointing to the first node in our chain. Right, but then if you recall, we also created another pointer called PTR, and that one was also pointing to whatever head was pointing. Because remember, when we first assigned it, when we first created, we did PTR equals head. right? So that whatever address is in head is also here. Then I did cout, and then I did ptr, and then whatever is in value, right? So this cout printed the 11. Then the next thing I did in my while loop is I reassigned ptr. I did ptr is now ptr next, right? So remember, here's the next, right? So this pointer, what I did was initially this. Now I'm pointing to next, but next is pointing to this. So then I can actually write it like this. Get rid of that. Now PTR's location, its address moved to this node. And then our while loop was while PTR not null. Right, so PTR is not null here because there's a value. So then I displayed now, first I displayed the 11, then the loop runs again, and then I display 9, and then now I reassign PTR to PTR next. So then PTR moves. So it's no longer pointing to this guy. Now PTR moves here. Now it's pointing to this node. This loop runs again, displays the 7. Then I reassign PTR. And then PTR now is pointing to this. So then finally the loop runs one more time, 5. And then I move PTR with this last statement here. And then PTR now points to null. So while PTR is not null, do this. The minute PTR became null, then our loop terminates. Right, so this PTR is changing, whereas our head is not. So if I need to traverse this list again, then all I need to do is just type this again, and then I can go through the list all over again. So that's why it's important to keep the head at the beginning of the list. Okay, so in the next video, this video's already gone on for about 20 minutes or so. I'm going to start going over more of the operations that you can do with a linked list, right? So that way it's a little bit more useful to you. But this is just the introduction, just to kind of get you started understanding how it works. Thank you for watching.